You're listening to the Bots and Bosses podcast, the only show where robots and humans attempt to work side by side. Presented by John Binks, technologist, author, and your AI Ringling tour guide. So, buckle up and let's deep dive.
So we're hearing that software development is facing this really seismic shift. Our source material is claiming it's one of the biggest changes since the entire industry went all in on Agile.
Which is a huge claim. I mean, Agile changed everything.
It really is, and it suggests we're looking at a fundamental redefinition of what it even means to be an engineer. So today, we're doing a deep dive into the architecture of this shift. We're focusing on a piece called The Future of Software Development in 2026. Our whole mission here is to pull out how the day-to-day workflow, team structures, and even, the basic expectations for talent are changing because AI is now so deeply integrated.
It's not just a tool anymore.
Exactly. Now, we pulled these insights from a different source, so just to set the scene, this material seems to be from another show. Here's the context it gave.
Okay.
Welcome to the Bots and Bosses podcast, presented by John Binks.
Right.
It says, this is episode 25, and originally aired on November 23, 2025. And one more thing, today's show is sponsored by Titan Technologies, shaping the future through innovative and transformational solutions. Check out their website at www.titantechnologies.com. So that frame helps, but the actual data is what we're here for.
Well, and what's so fascinating is that AI has absolutely moved past being just a simple productivity aid, just for auto-completing a line of code.
Yeah, that's old news now.
It's now a core generative part of the workflow. So the real challenge for every single engineering org isn't just embracing this, it's managing it. They have to blend that incredible new speed with just pure engineering discipline.
Because you don't.
If you fail, you risk building bad, unstable systems faster than anyone ever thought was possible.
Okay, let's unpack that then. Let's look at what an engineer's job even looks like now. The source says AI is now, and I'm quoting here, deeply integrated for all that foundational work drafting functions, generating boilerplate.
Writing documentation, surfacing improvements.
Yeah.
All this stuff that used to take up so much time.
Right.
And that capability, it delivers immediate speed. But speed is a dangerous multiplier. It introduces two really critical requirements that challenge those old sort of craft-based workflows.
And what are those?
First, you need much stronger oversight to verify the correctness of what the AI is putting out. You can't just trust it blindly.
Of course not.
And second, you need an extraordinarily high degree of discipline to maintain code quality and, security across a code base that's suddenly being written by multiple parties, humans and AIs.
So it's a senior engineer's job description. It changes from high volume output to high-level governance. They're not just cranking out code all day.
Exactly. The shift is complete. Their work moves entirely away from being a production function and toward an assurance function. They stop writing every line and they start making sure every line, whether it's human or machine written, is safe, maintainable, and actually aligned with the system's architecture.
They become, as the source puts it, reviewers, architects, and stewards of standards.
That's the perfect description.
Which brings up the critical question, right? If the AI writes the code, who's accountable when it all goes wrong, when a vulnerability gets exploited?
The core message here is just. It's unambiguous. AI may write the code, but humans remain absolutely 100% accountable for the outcomes. The human engineer is the final sign-off. They are the fiduciary responsible for validating that the machine's output meets all the requirements, the security protocols, everything.
So the role is elevated from just making stuff to managing critical risk.
It's a huge shift in responsibility.
Okay, so if the job is now governance and risk, how does that actually play out day to day? This is where the source gets really interesting, talking about daily discipline. It argues that things like security and QA, they can no longer be downstream checks.
They can't. That model is broken now. This whole necessity is a direct response to the new risks that come from automated code generation.
Like what?
Well, when you automate, you're integrating external code, external dependencies, maybe at a massive scale. And these suggestions, they might come without the full context on security or even legal compliance, like licensing. So to mitigate that velocity-driven risk, your teams have to fundamentally strengthen their daily routines.
Okay, so what does that actually look like?
The source outlines 4 specific non-negotiables. First, secure coding patterns have to be applied by everyone, every single time, consistently.
No exception.
No exceptions. Second, Dependencies need strict validation, not just for security holes, but also for licensing issues. That's a huge legal risk that automation can easily miss.
Right, the fine print.
Third, you need processes to ensure the AI-generated code isn't accidentally exposing your own proprietary data. And finally, QA and engineering have to collaborate continuously, not sequentially. They can't wait until the end of a sprint to start testing.
That makes perfect sense. If you speed up production, you have to speed up the quality checks to keep pace. But let's talk architecture.
Whoa.
If AI is just making code generation faster, why does the big picture architectural thinking matter more now?
It's the relationship between speed and failure. It's fascinating. Because AI accelerates production, a poor architecture doesn't just cause a slow, grinding failure anymore.
It's more dramatic.
It produces what the source calls fast failures. If your foundational blueprint is weak, the AI will build a massive, complex, and deeply flawed system on top of it, and it'll do it very, very quickly. The failures are catastrophic because they're structural.
Whereas a strong architecture
A strong architecture produces scalable, resilient systems. That's the differentiator.
So the argument is that organizations need a true return to classical engineering fundamentals to handle this speed.
Absolutely. You have to mandate clear architectural blueprints to guide all that high velocity work.
Okay.
You need modular designs, which really means you're limiting the blast radius of errors.
So if one part fails, the whole system doesn't collapse.
Exactly. And this also means strict human-enforced standards for naming, for structure, for documentation, and a peer review process that validates the architectural intent, not just whether the code runs. Quality has to start with design, not with code.
Okay, let's switch gears a little and talk about the human cost here, because the source describes this growing divide in the developer experience. For some, AI is liberating. It frees them up for design, for innovation.
The fun stuff.
Right. But for others, it's disrupting the creative, intellectual exploration that made the job rewarding in the first place. It's automating away the fun parts.
And this is a massive talent retention issue. Leaders cannot treat all their developers as one monolithic group. The data points out 4 things here. Motivation varies widely. Not all developers want the same relationship with AI, and autonomy is key for engagement.
And the fourth?
Crucially, that meaningful human-led challenges are still essential for morale. If you automate away all the interesting problems and just leave behind the supervision, your best people will leave.
Which implies you can't just slap an AI tool onto the old org chart and call it a day. The teams themselves have to be restructured.
Completely. Forward-leaning organizations are already creating new roles.
Yeah.
For instance, you're seeing dedicated technical stewards. Their only job is to maintain coding standards and architectural conformity across this new hybrid human-AI team.
And what else?
You're also seeing AI enablement specialists. Their job is teaching teams how to prompt, how to validate, how to use these powerful tools effectively. And critically, security engineers are now being embedded directly into development squads.
They're not in a separate department anymore.
No, they're right there day one. And QA professionals are participating throughout the entire life cycle, not just at the end.
That structural change really hammers home that message of integrated quality. Actually, before we move on to the leader recommendations, I just noticed a quick message embedded here in our source notes.
Oh, okay.
It just reads, if you are enjoying our podcast, please click like and follow our show.
A good reminder.
And it also says, and remember to tell your friends about our show. Okay, so back to it. These new roles really define what a 2026 engineering org looks like.
They do.
So with all these complex shifts in roles, in architecture, and teams, what does this all mean for leadership? Our source synthesizes 4 key priorities for engineering leaders moving into 2026.
And if you connect this back to that core conflict speed versus discipline, these 4 priorities are basically the playbook.
Mm-hmm.
The first is about skills. Leaders have to teach developers how to evaluate, refine, and validate AI-generated code.
So that's the new core competency.
It's non-negotiable from junior all the way to senior. Second, leaders must formally integrate security and QA into the daily workflow. This means providing the resources and the processes to make them checkpoints before code is ever deployed.
Not after the fact.
Never after the fact. Third, leaders have to consciously provide engineers with meaningful, human-led challenges. This is that morale and retention piece we talked about.
Yeah.
You have to reserve the really complex, novel problems for your human talent.
Keep them engaged.
And finally, the 4th priority is purely foundational. Establish crystal clear governance frameworks, robust coding standards, and precise architectural guidelines for all AI-assisted work. That ensures the speed you gain from AI doesn't sacrifice the long-term integrity of your systems.
So it sounds like the overall perspective here isn't one of doom and gloom, but I guess one of required maturity. AI speeds up the execution.
And humans ensure the excellence. The future is collaborative, but it demands much higher standards from both sides of that equation. The organizations that win in 2026 will be the ones that blend that AI-driven speed with disciplined engineering, thoughtful architecture, and a real understanding of what keeps their people engaged.
That focus on the human role is so critical, and it makes me think about those new team structures you mentioned, especially the rise of the AI enablement specialist. That fundamentally changes the requirements for an entry-level developer, doesn't it? Well, they have to be experts not just in code syntax anymore, but in prompting, in validation, in managing how effective these tools are. They're coming into a world where they have to be an expert in code and an expert in commanding the AI that writes the code. That's a whole new layer of expertise we've never really seen before.
That's a really sharp point.
And with that thought, we'll wrap up this deep dive into the future of software engineering. I have the final context notes from the original material right here. It says, today's show was human-inspired and powered with AI assistance.
Very fitting.
It is. Be sure to visit us, www.botsandbosses.com. And finally, remember, the bots are getting smarter, but you're still the boss. Thank you for joining us for this deep dive. We'll catch you next time.
Well, that's a wrap of this episode of the Bots and Bosses podcast. Enjoyed the show? Don't just listen. Follow the Bots and Bosses podcast and connect with John Binks online. Remember, the bots are getting smarter, but you're still the boss. For now, see you next time.